and it's the limit comparison test. So if you're given a couple of sequences, a sub n and b sub n, and they're both positive sequences, and you assume that the limit L as n goes to infinity exists for a comparison between them of division. So there is a number that you can actually calculate if you take these two series. Well, if the L value is bigger than or equal to 0, so that would mean it's positive, a positive number, well, then the smaller series converges on the top, the top series converges only if the bottom series converges. The bottom series diverges, then the entire limit won't exist. If the limit is exactly infinity, then, and we know that this converges, well, it'll only converge if b sub n converges. And if it's exactly equal to 0, so sorry, this should have been strictly greater than, well, then the b sub n converges. Only if the a sub n converges. So we can use this in an example. So if we start with trying to show that this infinite series converges, so let's start by defining our a sub n as that actual series, and then we want to choose a b sub n. We'll try 1 over n squared, and so L would be the limit as n goes to infinity of a sub n over b sub n. So the limit as n goes to infinity of n squared over n to the 4 minus n minus 1 times, and then since it's divided by b sub n, it's times n squared over 1. And so you can likely see that this is going to become just equal to 1. And therefore, since the infinite series 1 over n squared, this b sub n, this one converges, and our limit was bigger than 0 by the limit comparison test, our n equals 2 to infinity n squared n to the 4 minus n minus 1 series converges. And one last example for you. So we'll take a look and see if this series n equals 3 to infinity of 1 over square root of n squared plus 4 converges. I make my a sub n equal to 1 over n squared plus 4 square root. My b to the n, something very similar to this that I know diverges is 1 over n. And so I can set up my limit as n goes to infinity of a sub n over b sub n, and my limit as n goes to infinity of 1 over n squared plus 4 times, I flip this over, n over 1. If I were to calculate this, it will become equal to 1. So since n equals 3 to infinity of 1 over n diverges, and the limit is greater than 0, well, there's only one thing that can happen, which is a sub n also has to diverge, and again, it's by the limit comparison test. And that is all.